So hello everyone, my name is Tuan from the Department of Mechanical Engineering at NTUST. So today I'm really excited to share with you about our recent work on machine learning and GUI-driven approach to simplify DLP-based Microlens array fabrication. So this project combines optical design, machine learning, and user-friendly software to make the Microlens fabrication faster and more accurate. So the microlens array, or the MLAs, are small lenses structure arranged in a repeating pattern. They are used in the LCD displays to improve brightness, in live field cameras to achieve refocusing, and many other optical devices. So traditionally, making the microlens array requires precision machining and photolithography. While effective, these methods are either very time-consuming and very costly. So that's why researchers have turned into the digital light processing method, or DLP 3D printing. It's cheaper, faster, and more versatile. But even with the DLP, challenges still remain. The printed lenses often suffer from low resolution, high surface roughness, and dimensional errors. So our goal here is to address these challenges by combining the DLP with machine learning and a graphical user interface GUI to make the process more efficient and accessible. So earlier study introduced two main approaches. Firstly, defocused DLP, which shifts the focal plane to create smoother curved lens surfaces. Secondly, grayscale maps, which modulate the pixel intensity to control lens shape. Both methods improve the MLA fabrication but encounter some problems. For instance, grayscale maps are limited by projector resolution, and defocused DLP can be inconsistent. Also, some researchers began applying machine learning to predict outcomes, but these models often only predict one parameter, such as lens width, or require complicated coding. This limited their practical use for experimentalists. So our work builds on this study by proposing a more integrated and user-friendly system. So our aim is to develop a system that integrates machine learning and graphical user interface to automate and optimize MLA fabrication using the defocused DLP method. We'll focus on improving the easy-to-use, accuracy, and efficiency. So here is our process overview. As you can see, a PC-based software generates a grayscale mask and predict fabrication parameters using a chain neural network. This enables single exposure printing of microlens array with high accuracy. So moving on to experimental method. So our work has three key components. Firstly, the machine learning training a model to predict the MLA outcome. Secondly, GUI-based tools, making it easy to design and manufacture MLAs. And finally, performance evaluation, testing the fabricated microlenses to ensure the accuracy and optical quality. So for the machine learning step, we first design a set of experiment DOE using the Latin hypercube sampling LHS, then pre-process the data by removing the outliers and apply normalization. So a neural network model was then trained to predict the fabrication outcome based on input parameters. So now let's move into the details. So in the design of the experiment part, we use the Latin hypercube sampling, as I mentioned before, to generate a set of design points, which help reduce the experimental workload while preserving data diversity. So this will enable the machine learning model training with few examples. So instead of testing hundreds of combinations, as you can see here, LHS help us cover design space with only 36 experiments, which help us saving times and resources. Next. So next outlier were removed using the IQR method, and feature were scaled using the min-max normalization. This step ensured the model stability and faster convergence during the training. And finally, we trained the neural network to predict length parameters and height based on input parameters like grayscale, exposure time, and LED current. So the model, as you can see here, achieved high accuracy, indicating a very strong prediction performance. So as you can see here, the R square equal to a 0.9833, which is really high, showing that our work achieved the high accuracy. So here we introduce the GUI-based manufacturing step for MLA, which include program flow, design MLA mask through GUI, and choices of MLA model from the GUI. So in the program flow part, so first the user input the design parameter into the GUI. So next, the system uses a machine learning model to predict the grayscale pattern and positioning. So these are then used to generate a length, grayscale map, and pattern layout. And finally, the output goes to the DLP printer for fabrication. So here we introduce the major function of our GUI, designing MLA grayscale mask. This UI feature allows user to input design Microlens parameters such as length, pitch, diameter, height, and array layout. Once the parameters are entered, the system automatically generates a corresponding grayscale exposure map for the DLP printer. So let me show you the video here. So as you can see here, firstly we enter the design MLA information. Stop. And after that, we can show you the photo of the parameters so that we can input it into a DLP printing. So next, choice MLA model of GUI. So in this part of the GUI, user can select the machine learning model that fit their fabrication setup or data set. Since we train several ANN models with different configuration, such as varying training size, architecture, or parameter ranges, this module allows the user to switch between them easily depending on their need. So let me show you. Here we're testing the first prediction. We input it in test. And it can show you the model successfully. Also the diameter times everything. Alright. So here we show the manufacturing result and optical performance of various MLA. And the system achieved high precision with dimensional errors mostly under 10%, demonstrating sustainability for high resolution and optical system. So optical testing using the USAF resolution chart confirmed high imaging quality. And to summarize, we developed an integrated DMG GUI system combining a neural network and grayscale lithography. It streamlined the MLA design fabrication while ensuring precision and high optical quality. And yeah, that's it for today. Thank you for your attention.